Hello and welcome to the final and fifth class of the Introductory Java course, which is jointly produced by STEMEncounters and the Elliptic Collective. So today we'll be talking about object-oriented programming, and this is one of the most important and one of the first benchmarks in learning Java, and you really have to know this super well to be able to be proficient in Java and use it in the most efficient way possible. So let's first start with just a classic example of a class in real life because that will help you understand it better when we start implementing it. So a class in real life could be a human. It's essentially a mold. So if I took all the human beings on the face of this planet, alive or dead, however you want to call a human, then all of those follow a certain mold. For example, when you're born, you already have a certain number of bones in your body, you already have a certain number of arms. You can't really change that. You can, however, have different names or different ages for different people. So for example, I could create the Sally Walter object, which is called an instance of the human class. And Sally Walter has a name, Sally Walter. Her age is 15. Her life status, she's alive. Her birthday is May 20th, 2003. Those are all attributes or properties. She also has certain functions that all humans are able to perform. For example, walk, run, and sleep. So these are basically the properties of a certain class. So whenever you create a new object of the human class, you're always going to come with these attributes, and you have to set these attributes to certain values, and you can perform these functions on Sally. Like you can tell Sally to walk, you can tell Sally to sleep. So that's a very concrete example of what a class is. Now we can extend it to programming. So I'll first of all show you what the code looks like. So you have a pictorial representation. I called it person here, but it really is the same thing, so just reduce confusion. So this is your public class person. These classes are just another class. It's no different from your classical class here, except you don't really have the main method, but we're going to go into that a bit later. So these are your attributes, your name, your age, and alive, and I didn't really include birth date, but you could add it if you wanted to. These are called constructors. I'll get into more detail what these things are. I'll just give you the terminology so you have an idea what these are. So, constructors. These are all your methods below this. Oops. And there actually are different types of methods that I will discuss in more detail. So I just mentioned how classes act as a mold. So first things first, you want to know how to create an object. Like how do you create that human? So there are things called constructors that are in the human class, these guys, that allow you to create a human. So when I'm in my main class, if I want to create a new Sally with the age 10 and with the alive status, then I can invoke this constructor, which is telling me I'm creating a new person with this age and with this name. So I'll be using this certain constructor. However, if I would only like to create a person with only an age, I can do that as well. I can just put, instead of a name here, I can just remove name from this parameter set and just have that. Then her age would be 10 and her name and aliveness would not be having any value. You're probably wondering, what is this? So this is telling you which object you're currently in, because you already have two variables with the same name, and of course these are generally discouraged, so that's why you cannot write age equals age, because no one's going to know which age you're referring to. But if you write this, then you're telling the system that this age is the one of this current class. So I'm talking about the class's age, this variable. But this age would be talking about the one from the parameter. So if you want to reduce confusion, then what you can just do is name this something else, like age. Then you can get rid of the this. Age. So if I have the number big age equals 5, then by invoking this constructor, that is telling me that this age is now set to 5. Alright, so that tells you what constructors are. Now, methods are certain functions. So you may remember from Algebra 2, if I have a function, then I'm taking some value, say 2, and I'm mapping it to a certain number, say 0. So these are your methods, your functions. So each of these are called methods or functions. There is a certain format you must write them as. So these are called modifiers. So when you're looking at your method here, this public part is called a modifier. So these can be any of the following 4, and generally you only use public and private. And generally you only need public. You only really need private or protected or private. So for example, if you're working in some really big company and you need certain classes that cannot be accessible to other people when you're sending your code to other people. So this is just a general guide as to where it is accessible. We don't really need to get into that much since you're really just working on your own time. It's your own computer, so in general you always want to use public. This part tells you what the method returns. So if it says void, that means I'm not returning anything. All I'm doing is doing whatever's inside here. However, I'm doing int, then I need to return an age. So if I say get age, that means this is going to be the value 10, because I already set the age to be 10 here. Like I've already created that object, so already be 10 here. So when I'm calling get age, this is just going to give me the number 10. So these things inside the parentheses are called the parameters. So that's what's telling you what you need to put in for that to be called. So for example, when I'm calling set age, I need to put an integer in here. When I'm calling get age, I don't want anything inside my parameter list. And in your main method, as I said, you can create your human object using these constructors, as I mentioned here. These are your constructors. And you can call your methods on this object. So let's just do an example. I start with an age, a live status, and the name. So I can create a person named Sally with that age. But in this case, I'm actually not adding the name. I'm only creating the Sally object with the age. So this one actually does not have to be the name. I could do whatever I want here. I just did it for simplicity's sake. I'm just called Sally. So if I want to put a name in there, I need to remember to follow this formatting. This order is very, very important. So I put name. Then this is saying Sally's age is Sally got age. So Sally got age would get me 10. And I'm setting the age to be 20 now. Sally's already 20 years old. So now she's now aged 20. And then Sally can walk. So there are certain names to these methods. These are called setters. These are called getters, and these really don't have a name. Setters basically can set your variables, your class variables, to a different value. Getters, as the name suggests, you can get the age. So I'll just run this, and you have an example. See, this is Sally's age is 10. Sally's now age 20, and Sally's walking. So that is approximately how classes will work. And I will have an assignment for you guys to practice writing object-oriented code, since those are so important when you're dealing with Java programming. And there are methods I do want to talk about in your public class that are not really related to object-oriented programming, but they're really, really useful. So let's just delete all this. And now I'm just going to talk about methods. So methods are basically functions that are really convenient, because if I wanted to compute some really complicated math scheme here, I want to divide by 3 and then add 4 and add 7 in the middle of my code. I don't want to have an entire segment dedicated to it, because that's so many more variables you have to come up with. For example, if I said int I equals 2, and then I had to do j equals I plus 1, and then j equals I plus 2 divided by 7 and then times 5, then that kind of gets really complicated. Like, this is really just a simple example, but I just want to show for an example. And sometimes, especially when you're working in some more advanced math or even computer programming, you can have some super complicated expressions. So to simplify this, you can put all of this in a different method. So if I create a method called public static int compute, so what this will do would be, yeah, I haven't finished the method yet, so it's giving me an error. But it would, if I put in the number 2, if I called it, then say I could do int j equals 2 plus, or I plus 1, and then j equals I plus 2 over 7 times 5. And then I have to return j. That's really important because this has to match what I'm returning. I cannot return a string here. I cannot return a double here. It has to be an int. So now, instead of having all this complicated stuff, I can just do that. And this will give me exactly what I want. I'm assuming that's probably what it would give you. As it would be 3 plus 2 over 7, which is 0, times 5, which is still 0. So it is correct. So that's what methods are. It's basically a separate place. I can take that code out and compute it elsewhere. It's exactly the same code. If I put this section as I did before in here without the compute, without this method, then it's exactly the same result. It's just simpler and easier to look at. Final thing, I just want to discuss a huge misconception with methods. So if I had compute here, so I put int a, had a here, and I said int a equals 1. And somewhere along here I put a equals a plus 1. Then you would think a does become 3 here. But when I print a here, or right after the method, and I print a right here, a does not change at all. It's still 1. It's not going to become 2. So you have to be really careful because whatever is done out here, unless you're returning it, it's not going to change any of these variables. You're actually not really changing I either. Like, for example, if these were all called I, like if I just said I equals I plus 1, so on, and I said return I, then I'm not really changing I just by calling this. I set I to the new value. So say I want to write I equals I plus 1 and I equals that. And just by calling this thing, if I just put this and I printed I, oh wait, sorry, this is void, then I is still 2. Because what I did was I set I to be what it was supposed to return. So this was int, and return I. So whatever's on your method is never going to change the original values here. You actually have to set it to the new value. So that's why you have to be super careful to make sure that whatever values you really want back from that method, you're actually returning it and setting it to the variable. So that's all I have for you for the introductory Java course. Always remember that if you really want to improve on your Java programming skills, the best thing to do is to do so many exercises because that will get you so familiar and you'll be able to learn more Java programming skills if you're already familiar with the basics. I will have an assignment posted and you guys can work on it in your own time. And thank you for joining in on the course.